In the first part of this tutorial on data analysis, we will be having a look at the training session that was conducted over a period of 4 weeks. I'm already logged into my server account, and under my data there is the day-by-day analysis, which gives you essentially the same view as you will have on the RyngDyng app when recording the data. You can select the dates, and the training session started from 2nd of August and the final day was 28th of August. I select the first day, and it was a 122 centimeter target at a distance of 70 meters. Whenever you click on the button here, you can retrieve all the configuration data that have been used when recording those arrows. So you can read 70 meters and a 122 centimeter target, and let's say all the other parameters that have been used when shooting these arrows. The first thing you can do is to browse through all the ends. We have 24 ends. There are browsing buttons here, the small ones, but the larger ones here below that are better suited for mobile phones. And then you can have a look at the individual ends. It's always possible to overlay ends, whatever you like. And for example, when you overlay 3 ends, you can browse through the overlaid 3 ends as well and see how your grouping develops over time in that day. Most important is also the possibility to overlay all ends. So these are all 144 arrows of that day. And the scatter ellipse, together with the grouping center, clearly indicates that there is a problem with the centering. And during the coming days of this training session, you will see that the sides has been adjusted so to get the group center into the center of the target face. Below there are all the statistical figures, such as the AGI, the arrow grouping indicator. 94.8 is a good figure, not yet good enough to be a world champion, but this is okay for the beginning. The number of arrows, the number of points achieved. Here is the translation of the group center. We are out of center by 3, respectively 4.5 centimeters vertically. There are the dispersion figures that we will discuss later, and the graphs that show how the scoring developed over time, and the grouping indicator and the points per arrow figure. So this is the view of a day-by-day analysis, and we can jump into, let's say, the middle of our training session. Let's choose that day. And as you can see, the centering of the group has been improved. Now we would like to have a view where we can compare all these key performance indicators over time, over a period of 4 weeks. This is what you can do with the advanced activity and performance analysis. I'll select this view, and here the start date. This was in August, cover all August, so I just select 1st to 30th of August and run the analysis. This takes some time because these are thousands of arrows, and the analysis is heavy computation. Okay, here the results pop up. These are the overall figures. 1,870 arrows. overall we have achieved an AGI, a grouping indicator of 95.0, and we achieved 9.27 points per arrow. The next two graphs are on a timeline. You see all the days, and the first graph shows the number of arrows shot on each day. From this figure you can see that the number of arrows shot is constant, always 144 arrows, but there was always a day between the training days. There is always a day left, here are 2 days left, and so on. So this is 1 week, 2 week, 3rd week, and the last week. On the last week we have 2 consecutive days of training. Now if we look at the key performance indicators, we see that the AGI, the grouping indicator, has a positive development towards the end. So there's a slight improvement over the 4 weeks. It's actually hard to improve on the AGI to get the groups more narrow. That is the hard part of the training. But you also see that on the last day there was a drop. So apparently shooting on 2 consecutive days that many arrows is probably not the best idea. So if the last day would have been the competition day, I would say that the preparation for this competition with a training exactly the day before is probably not the best idea. The blue line indicates the achieved points per arrow with the scale to the right. So we started with 9 points per arrow and improved up to 9.4 points per arrow, and also a drop. Now you might ask, why is there a large difference between the grouping and the points per arrow at the beginning, and the gap is closing towards the end? Well, this is exactly the adjustment of the centering of the group. We started with a quite okay group here, narrow grouping, but the center was not aligned, and this is why the points per arrow figure is lower. And then we adjusted the sight from day to day, optimized the sight adjustment. We got the group more into the center, and this is why also the points per arrow figure improved over the 4 weeks. So this is the overview of a typical training session that was conducted over 4 weeks and was intended to serve as a preparation phase for an important competition. The next part of the tutorial is about tuning of arrows. When you buy new arrow shafts, you would practically start with a too long arrow shaft and then cut it by pieces until the arrow fits the bow. And this is typically be done by conducting tests with unfletched arrows and compare these to the fletched arrows. Here is a sequence of arrows that have been shot on a 40 centimeter target in order to tune the arrow shaft. The arrow shafts have been marked with blue color. You can essentially just click on an arrow and then switch on the bare shaft property, and then the arrow will be marked as a bare shaft, an unfletched arrow in blue color compared to the others. The ends have been shot with 6 arrows each, with 5 fletched arrows and 1 unfletched. So if we browse through these ends, you can see there is always 1 arrow blue, which is unfletched. Now, the tuning has been conducted in a way that to each arrow shaft length there have been shot 3 ends. So if we select 3 ends, we get a picture showing the fletched arrows, 15, and their respective scatter ellipse and the grouping center, and separately the 3 unfletched arrows in blue with their scatter ellipse and their arrow center. Now, this situation that the position of the bear shafts is right to the position of the fletched arrows indicates that the arrow is still too soft in a right-hand bow situation, and therefore the arrow shafts need to be cut. What has been done after these 3 ends is to cut the arrow shaft by 1 or 2 millimeters and then shoot another 3 ends. And this is what follows. Ends 4, 5 and 6. They are 3 ends with the cut arrows. And you can see that the difference between the bear shaft and the fletched arrows has become smaller. Then another cut, and again 3 ends, and we are still approaching the fletched arrows. Another cut, ends number 10 to 12. We are getting close to the fletched arrow positions. Always look at the group centers here. This is important because a single arrow, if you just do 1 end and you don't overlay 3 ends, at least 3 ends, the statistical significance of the positions would be misleading. Another cut. You see, we are almost there, so our unfletched arrows are now almost at the same horizontal position as the fletched arrows. A final cut, small one, and this is end number 16 to 18, showing that our unfletched arrows perfectly match the position, the horizontal position of our fletched arrows. And this concludes the arrow tuning, and we have got a very well tuned overall system. Different types of target faces provide a different image to the aiming eye. So the question is whether your performance depends on the appearance of the target. Again, we start with the day-by-day analysis, and I have recorded arrows for 2 different types of target faces. The first one is the standard 3 spot, and if we select all arrows, we can see that there have been 120 arrows. The grouping is quite okay with 95.3 AGI, and this view also allows to have a laid out view of the different spots, or select only the upper one, the middle and the lower. This already gives an indication that, for example, in the middle spot there is a higher vertical dispersion compared to the upper and lower spot. So this is another point that's interesting to follow up in a data analysis. We will do that later. On another day, I have recorded the same amount of arrows, 120 arrows, on a Las Vegas type of spot. It's also a 3 spot, but they are arranged differently. So the question then is there a difference to the aiming eye whether the spots are vertically aligned or whether they are aligned in a triangle like this? We can have a look at the AGI, which already gives us an indication that the AGI of the Las Vegas spot is lower, but I would like to do a direct comparison of these 2 results for different target faces. This is why I'm going to run a special comparative data analysis. This allows me to select a whole range of days where the target phases might have been different on different days. And it allows me to select a comparative analysis, like, for example, the scatter ellipses per target type and distance, which I'm going to select now. Run the data analysis, and this gives me a very comprehensive view of the comparison of the two types of spots. Left is the 3 spot, the vertical aligned 3 spot, 120 arrows, 18 meters distance, and with an AGI of 95.3. And directly to the right there is the Las Vegas type of spot, same distance, same number of arrows, and a lower AGI value, so the grouping is worse than on the left. But you also see that the shape of the scatter ellipse has changed. The white spots here are kind of a heat map of where the arrows actually sit, and this also indicates that the scatter ellipse is first of all longer in the vertical direction, which indicates a higher vertical dispersion, but it's also tilted by an angle. This typically is a sign that your dispersion is not equal in all directions, and there is a reason why the dispersion tends to be towards the upper right corner or the lower left corner, why there is a tendency for the arrows to move in this direction. And as everything has been kept the same for these two target phases, except the arrangement of the 3 spots, the conclusion is that the visual appearance of the 3 spots, their arrangement, leads the aiming eye somehow in different directions compared to the vertical aligned spot. And once you have got this information, you can try to specifically work on that problem. The next part of the tutorial is about a dedicated data analysis regarding 3 spots. We have recorded arrows on a couple of days that were targeted at a vertical 3 spot, standard 3 spot, at a distance of 18 meters. What we are going to analyze is whether the dispersions are equal on all of the 3 spots. To do this, we go to the comparative data analysis, select the days that are relevant for this analysis. So these were the 2 days where we have recorded our 3 spot arrows, and we select the spot analysis. This analysis shows us the scatter ellipses for all of the 3 spots, so the upper, the middle and the lower spot. On all of the 3 spots, 80 arrows have been recorded, and the AGIs, as you can see, are above 95 for the upper and middle spot, which is the red and the bluish kind of scatter ellipse, and the lower spot with the yellow ellipse has a lower AGI and a worse grouping, as you can see. The centering is more or less the same and is okay. Now the question is, why is this? So the next thing we will have a look at is the sequence of arrows. In which sequence have the arrows been shot on this target phase? So we select the AGI, dispersions analysis versus arrow sequence. So this is a dedicated analysis for each end. We take the first arrow, the second arrow, the third arrow, and have a look at all first arrows together compared to all second errors, compared to all third errors that have been shot. Press Run Data Analysis. And a few seconds later we get the result. We see all the key performance indicators for the arrows number 1, 2, 3 that have been formed as a group. We can see that we have 80 arrows each, so 80 first arrows, 80 second, 80 third arrows, and the arrow grouping indicator is the lowest on the last one, so number 3. The archer has shot the first arrow on the upper spot, the second on the middle spot, and the third arrow on the lower spot, and the lower spot gives us a lower AGI and also a lower point per arrow figure. If we look at the dispersions, we clearly see that the vertical dispersion is the problem on the lower spot. The horizontal dispersion, which is the red bar, is more or less the same on all spots. It's a bit higher than the vertical dispersion here on the upper and middle spot, but on the lower spot there is a high vertical dispersion, and this is why we get the lower AGI value. Now the coach has told the archer to change the sequence. On the next days, the archer shot the first arrow on the lower spot, the second on the middle, and the third on the upper spot. And this is the result in terms of spot analysis, what happened. Now the 3 scatter ellipses are more or less identical, so there is no longer a bad performance on the lower spot, which is now the first one that has been shot. It's the yellow scatter ellipse, which is roughly the same as the other scatter ellipses. And this way the problem could be solved. What the mechanism is a different question, whether it's the aiming eye or whether it's a different focus when you shoot your first arrow compared to the second. That's a different question. But the result of this change in the sequence is an overall better performance regarding points per arrow. If you are interested to learn whether your performance depends on the used type of material, that's also possible. For example, you might want to change the type of arrows and see what the impact on your performance is. We have recorded a couple of arrows on one day using a specific type of arrow. When you hit the button on the settings, you can read this was an Eastern ACE arrow, and this is the overall performance. So good centering, quite okay grouping, 9.4.2. But the question is whether another arrow might be better than that one. So we have tuned another arrow and used that one on the following day. It was a Victory V-Force 245 arrow. Again, having a look at the scatter ellipse, very similar, and also, yeah, the AGI is lower than with the ACE. Now imagine you have used this not only on 2 days, but over a certain period of time, months or weeks, and you want to have a consolidated view on what is the result of the one type of arrow and what is the result of the other type of arrow. This is what the comparative data analysis does for you. First, you select the period in time you are interested in. Then you select the AGI versus used bow and arrow analysis and run the analysis. This is how the result will look like. As said before, you can use any period in time, such as months or half a year, and use one bow or arrow and compare this to overall to the other one. Again, you see that the victory arrow has a bit lower AGI value than the ACE. Also the point per arrow figure is a bit lower. This is only a small number of arrows, so 72 arrows each. This is statistically a bit insignificant for such a big decision which arrow to use, so I would recommend to rather shoot a couple of hundreds of arrows to really see the difference. The arrow grouping indicator, the AGI, is calculated in a way so that it is independent on the shooting distance. Essentially, it becomes a measure of the angle dispersion. Here, on one of the days, we have recorded a couple of arrows shooted at a 122 centimeter target and shoot the arrows at various distances. For example, the first 6 ends have been shot at a distance of 30 meters. Of course, the group gets narrow on a short distance and a large target phase, but as said before, as the AGI is calculated in a way so that it is independent of a distance, this gives the same AGI, roughly, that the archer achieves on 70 meters. The following 6 ends show a larger group, as it should be, with roughly the same AGI value again, and it has been shot at 50 meters distance. Likewise, the last 6 ends have been shot at 70 meters distance, and they form a larger group with an AGI of 94. The dependency of the AGI versus distance is a very important means to analyze your shooting style and your release. Therefore, we have provided a specific analysis, a comparative analysis, on this combination of AGI versus shooting distance. We select the day and the AGI and dispersions versus shooting distance analysis. And this is how the result looks like. On the axis you see the distances. We have used 30 meters, 50 meters, 70 meters, shot 36 arrows on each distance, and the yellow line clearly shows that the AGI is decreasing with increasing distance, so the groups are tending to become larger. And if we look at the normalized dispersions, we can identify the cause of this worse grouping. It is because the vertical dispersion, the normalized vertical dispersion, is increasing. The horizontal dispersion is more or less constant and independent of the distance, but the vertical dispersion is increasing, causing the lower AGI. The conclusion from this is that the dispersion, the vertical dispersion, is not only caused by varying parameters such as the sight or the precision, how you hold the bow. This is only possible, the increasing normalized dispersion on the distance, because the launch speed of the arrow is varying. So you have a dispersion in the launch speed, which translates finally in an increasing normalized vertical dispersions. This is due to the form of the trajectory of the arrow on large distances, which is a loop with a peak. And if you cannot launch the arrow at a very constant speed, this will translate into a higher vertical dispersion. If you launch the arrow at a slightly higher speed, the arrow will hit the target above the center, and if the launch speed is slightly lower, the arrow will hit the target well below the center. And if you vary the launch speed, this translates into this high normalized vertical dispersion. Now, when you see this pattern, then you can conclude that you should work on your release. Releasing the string with the fingers is most probably the cause why your arrow has a varying launch speed.